Hi guys, it's Mr. T again, and today we're going to talk about statistics. And this is part one of three parts, and this is just going to be a quick overview of the idea of statistics. And we're going to be using a packet, and this packet actually has two sections that deal with probability as well, and then there's a separate section on probability that deals with set notation. And so that's what we're going to talk about today is statistics. But what are statistics? Well, there's several different fancy quotes out there you could look up about statistics. But what is statistics in general? Statistic means the collection and organization and understanding of different types of data. Okay, and so that's kind of what we're focusing on is that how we're going to collect it and how we understand the data. And then how do we use it? Well, we can, when we collect it, we can put it in all kinds of charts and all kinds of things like tables and things like that. Pie charts, everybody loves those kinds of things. We can even use some Venn diagrams, which we probably focus more on when we get to probability and set notation information, which is a little bit different about intersections and unions. So that's coming up. But today we're just going to be talking about um, the introduction here of statistics. Okay. And if you didn't notice, it's kind of Christmas time, and we got all of our carefully hung up stockings here. One of my wife's favorite things as part of our decorations. Well, I'm going to turn off the picture here. I'm going to put on the headphones today, and to get a little better microphone pickup. Here we go. Here's some statistics, and the what we say here is we're going to determine the differences between randomized experiments and observational studies, is what this talks about. Now, that's the current wording for that same standard. That's a little bit older standard, but it's the same idea, is to recognize the purposes of and differences among sampling surveys, experiments, and observational studies. Explain how randomization relates to each. So we're going to be talking about how do you take a survey and to get the least amount of bias, what kind of sampling methods you would use. Um, are some of these studies really experiments or are they observational studies? And how does randomization fit into the big picture of things? So that's what we're kind of looking at as we're looking at some of these definitions right here. So to begin with, we talk about a survey. Well, in a survey, it's a specific group of people who is asked a series of questions about the topic under consideration, whatever are talking about. And then it talks about, hey, when you're designing your survey, there's some stuff to keep in mind. Remember, there's lots of ways you can give a survey in person, online, phone, by mail, lots of ways to do that. Carrier pigeon doesn't seem very effective, but I guess you could do that. Okay, and there's some survey results can be affected by the wording of the question. So you got to be careful of that as well. We also don't want to introduce bias if a population, that means a group that you're studying, doesn't really get represented equally. All the different kinds of groups that you'd be looking at don't get represented equally um, in your survey. And then survey results may be affected by respondents not answering truthfully or completely. And then we'll get more into that and we'll talk about bias in just a moment. Okay, so when you're taking a survey or a study, we can either do an observation study or an experimental study. Okay, so we got observational study and experimental study. An observational study is just the group being studied is observed any without any intervention on the part of the researcher. That's the fundamental thing. Cannot have any connection with that. You're just simply observing. Okay. Where an experimental study, the researcher will collect the data just like they would in an observation, but they're going to intervene in some way in the population study and then collect the data again to study the effects of the intervention. Intervention? What do you mean? Well, let's just say one year I made some observations on my grass and how it grew. And then the next year, I left half the yard just like I had done before, used the same kind of techniques to care for it. But the other half, I used a new fertilizer. Okay, somebody said, "Hey, won't you try out our new fertilizer?" And so they intervened in what I was normally do and gave me a new kind of fertilizer, okay, to experiment with. And then the side of my yard that I kept the same, that would be my control group. And so if both sides of the yard look the same at the end of the season, then I can say the fertilizer didn't really work because it looks just like the side that I did it normally, because that'd be a control group. And so that's a better kind of experiment. So it doesn't have to have a control group to be in an experiment, but it's the best way to do that. Okay, if it's going to be a controlled experiment. Okay, now there's several ways to take a sample of a population. Okay, for a survey or a study. Now, random samples and bias samples each have their place in data collection. So each have their place. People don't always remember that. Okay. In a random sample, no part of the population is favored over another. And so a random sample was more likely to lead to a sound conclusions. Okay. So this is what we're looking for. But in a bias sample, one or more of the parts of the population have a greater likelihood of being included. Okay. And so, however, a bias sampling is generally easier and cheaper than random sampling, and it can be necessary when random sampling is not feasible. It's just too expensive to do some of that sometimes. So, it doesn't make bias sampling useless. It just means you got to remember that it is biased and however it's being affected. And you're like, well, why would you ever do that? Well, we do it all the times with like Amazon reviews. We know that those are biased, and if you don't, let me tell you, they're biased. People that are get really excited about it, they write it. People who are really mad, they write a review. And so as long as you keep that in mind, you can still learn something from it. You just got to keep that in mind. So okay, so we got observational, without intervention, without interference, experimental. Hey, we're going to break you up into groups, and I'm going to give this group this, and I'm going to give this group that. Okay, that's experimental. Okay. So even when you're trying to do the right thing, you can bring in some bias. So we got to be careful with your survey bias questions that can influence how people respond. So would you like this beautiful item A or this nasty old item B? Now that's an exaggerated sense of bias, but you can create an influence on how you word things. So they want your wording to be as neutral as possible when you're taking these surveys. How about the interviewer effect? So, um, say how often do you cheat on tests? Well, if your teacher's asking you that, your answer is going to be, "I never cheat on a test," right? But if you're talking to some other somebody you feel comfortable with, maybe that number is a little different, right? I hope it's you never cheat on tests, sure, but I know that's probably not always true. But so if your teacher's asking you, I can be affecting the results. Um, just like in class, sometimes when I ask questions, sometimes people are unwilling to answer because they don't want to be embarrassed. Okay, so that's the interviewer effect, and you can kind of understand now. Now, non-response bias is a little bit tougher. So some people may be difficult to contact or may simply refuse to participate once contacted. If non-response rates are higher for a certain subgroup of a population, then those subgroups will be underrepresented in the survey results. And so your analysis of the data may be off. Um, I know in the election several years ago, there the surveys that people were doing and their predictions were off. And one of the reasons that they said that the results were off is that there were certain groups and there were a whole bunch of them that just didn't participate in the data collection. So when they were making their predictions of who was going to win, those people weren't represented. So their predictions were off because they didn't have the data. So this make and it's a real hard thing to accomplish because exactly how many people did not participate and what might they have and why did they not participate? And so working through all that becomes very challenging, but that can have some errors and bias to your results. So those are things to remember as well. So let's go back to our sampling. So those ideas, but now we're going to talk about sampling. Because if I want to know something, just some kind of information from a really large group of people, it's not really easy to ask every single one. And even if I tried, I can't. Somebody's going to be absent. Somebody's going to refuse to fill it out. So what we do is we get a sample, a small group that should represent the bigger group of whatever we were talking about. And so what kinds of sampling methods are there? Okay. Well, now at the bottom of that first page, it has random samples and biased samples. And so there's two columns. But I'm going to show you here that has some little icons, and we're just going to walk through them and then we'll talk about which column you would put it in. So our first sampling method here is simple random. This is the one you want. And you see over here on the icon, it just got random dots selected. And so this is what you really strive for anytime you can. Our next little icon here is self-selected. And so you see there's a kind of a cluster here and there's kind of a pattern going along. These are self-selected samples. These are individuals who volunteer to be a part of the sample. This can say, well, that's great. I'm glad you were going to participate. Well, this can introduce bias, just like the Amazon review thing, because or a book review, that any of those kinds of deals, they can introduce bias. They either really like it or really don't like it. They've chosen to be involved in this process, so more neutral people aren't even being representative in that sense. Okay, so we're going to call that a bias where um, simple random is our best. Self-selected is probably one of the worst kind of biased, but it doesn't mean it's useless. Then convenience sample. Okay, well, let's say I wanted to know something about how the whole school feels about something. Well, but I don't want to mess with going out and trying to get a representative random sampling from all the different groups in the school. I just decided to survey one of my classes. Well, one of my classes is an honors algebra 2 class. And mostly 11th graders, a few 10th graders, right? Is that while they're great folks and I'm glad to have them in class, do they really represent all of the school? No, they're mostly, 11th graders and some 10th graders as well. They don't represent the whole school. Freshmen aren't represented at all. Seniors aren't represented at all. So but it is awfully convenient. Okay. It's awfully convenient to me if I wanted to do that. So that's a convenient sampling. And then there's a systematic sample. So convenience sample is also in the bias section. So self-selected and convenience in the biased. Now systematic is not so bad. You see here we got these systematic patterns. It's every other column. And so in a systematic sample, members of the sample are chosen according to a rule, such as every nth person, like every fifth person or every 10th person in a population. Okay. And then now it gets kind of murky a little bit. So, but those are the most normal kind. But I'll see if I can explain stratified and clustered. Now, stratified and clustered is what you do is you're going to take your larger group and break it up into smaller groups. And just for an example, let's think about a high school that has 9th, 10th, 11th, and 12th graders. So that would go with this picture. With the stratified sample, you would take one random freshman, one random sophomore, one random junior, and one random senior. So you're breaking it up into groups and then random inside the group. So that's a stratified sample. And for a school, that's probably not a bad idea. That way you get all the ages represented that way, and it's still random. But a cluster, that's a little different. Again, we got this 9th, 10th, 11th. What if we just picked the 9th graders and the 10th graders, or the 10th graders and the 12th graders? So, but what would you do is you'd pick one group and then do everybody in the group. Okay, every single person in that group. That's called a clustered sample. So there's still some random because you're randomly selecting the groups. So those are some different samples. All right, let's look at some examples here. Okay. All right, the officials of an um, NFL want to know about how players feel about proposed changes to the rules. So they decide to ask a sample of 100 players. Now, they're going to talk about 3 different ways that they can make that choice. One is the officials could choose the first 100 players who volunteer their opinions. Well, if you look down here, it says at A, it says this is a self-selected sample because the players who volunteer their opinions, okay, this could result in a biased sample, right? Because the players who feel strongly about the rules would have the first ones to volunteer and get their opinions counted. So taking volunteers is probably not the best choice. Now, B, it says the officials randomly choose 3 or 4 players from each of the 32 teams, which is how many teams there were when this was printed. Well, is that a good idea? Well, what kind of sampling is that? Well, that's a stratified sample, okay? Because the players are separated by teams and then randomly chosen. Not a terrible way to do it, right? This is not likely to be biased since the players are chosen randomly and are taken from each team. Seems like a pretty good choice to me. Each team's going to have somebody on there represented. So that guarantees every team's represented. Okay. But then you have C here, and the officials have a computer randomly generate a list of 100 players from the database of all the NFL players. So now it's every NFL player randomly selected. And we're going to say that's the most random. And that's generally what we consider the best choice. D is the most random you can get, is the best choice. Now, 100 players, that may not be enough people, but that's a whole nother issue for margin of error. So the book would say C is the best choice, but B is awfully pretty good choice as well, right? Okay, so now let's go to some other examples you have in your packet. So on page 2, we have some examples here. And I'm going to encourage you to pause the video and work these out for yourself. And then I'll try to briefly go over some of them. So hit pause now. Okay, I hope you did that and you just didn't let the thing keep on playing, because it'll be more effective for you if you've tried these first and then kind of got along with what I came up with. All right, so what we have here is we got a principal who wants to know whether students like pizza as a lunch option every day. Okay, so this is an important word. What do they want? Okay, and then they're talking every day. Now the survey of every other student, who they survey? Every other student in the cafeteria during lunch. It says, what is the sample? What kind of sample is this? Was this sample all football players? No. Every other student who entered the lunchroom? Looking like that one. All students who buy lunch in the cafeteria? Well, that's not a bad idea, but it says every other student. So this is a systematic choice where this is an all kind of issue. And then all students in the school. That's not that's a pretty good idea, but that's not what they did. The question is, what is this sample? Not what would the best sample be, it's what is this sample. And that is the deal there. So B was the answer to the kind of sample that this principal chose. Now 4, telemarketer calls every hundredth person in a phone book that they used to have these big old books with a lot of numbers in them. Okay, now you just look it up online mostly. Now, which type of sampling method did he use? Not what kind you suggest, but what did he actually do? So was it random? Not completely. Was it convenient? Well, I guess in some ways you might think convenient because you didn't have to go around finding the numbers. You just grabbed the telephone book, right? But systematic, I think systematic is your better choice there because it's every hundredth name in the phone book. And these people weren't self-selected; they didn't volunteer to be called. So that would be a systematic sampling. Okay, we can go to the next page here. We got a research agent wants to determine how many. So again, this idea of what do they want? That's important. Okay, how many hours per day? How many hours per day? And who do they want? Everybody in the U.S. How much time do they watch television? And so, and so in this one, they're not telling you how they did it. They're asking which way would give them the most representative sample. Okay, you can't get it perfect, but which one would be the best one? So our first one, we got a survey of 1,000 households in Alabama. Hey, I'm from Alabama. I live in Alabama, and that seems like a great idea. Well, let's look at another survey: 1,000 randomly selected households in the U.S. I guess that's okay. 1,000 randomly selected households in the Northeast. How about 1,000 households in 5 states? Well, the deal is this, okay? As much as I like Alabama, no one state represents the entire United States, so that's going to bring some bias, okay? It's random and it's US, so that's going to be our best choice because what do they want? People in the US, okay? So that's all the people. Um, Random, that's good, but then it said what? Northeast. Again, that's one section. And now surveying 1,000 households, that's kind of stratified, which is in 5 different states. But again, 5 states is not as good as straight, bona fide, random. Okay. All right. Then number 5, it says a company wants to know if its employees are satisfied with the company's vacation policy. Which sampling method would give the most representative? Okay, they give some survey cards outside of human resources. Well, that's awfully convenient, right? So that's a convenient survey. Well, let's try this. That's a convenience. So survey all the employees with children. Uh, hmm. Survey every 10th employee. How about every 10th employee who work on Friday? Oops. So that whole thing, that's going to be biased, right? Because that's just the people who work on Friday. This is biased because that's just about people who have children. That's convenient. Not everybody comes by there. Not everybody's going to fill it out. So we're going to say every 10th employee is our best choice of the ones we've been given. Okay. Pharmacy. Okay. Local newspaper. Okay. Where's the key word? Volunteer. Self-selected. Okay, I'm just trying to pick up the pace a little bit here. We got a school. I'm changing the mascot. School mascot. So we want to see all of our students, right? Okay, least likely, okay, it's not perfect, bias the sample. So survey students in the cafeteria, that's not bad. Every 5th student enters for school, that seems like a systematic. Survey your friends, oh, that's definitely convenience, right? That's going to produce biased. Survey every student from the school who attends. Okay, every student, that's good, but they have to attend basketball. Okay, again, that's a convenience. Um, one group being overly represented. So, um, what group won't be representative if we do every very 5th student who enters the building before school? What group won't be represented? The people who are late, and hopefully that's not too many. But this is the best one right here, okay? Because that's going to get a cross section of everybody coming in the doors. Okay, this next page deals with types of studies. This first one's, yeah, it's okay. The official answer to that one is C. Okay. This next one here talks about cold remedies is an experiment. So the first one talks about giving a cold remedy A and giving it to B to people with colds, and then observe the duration of the cold symptoms. So researchers give, okay, that's important words. Researchers observe the symptoms. Definitely not experiment, right? Researchers ask, mm, uh, include questionnaires. That's self selected. And did they do anything to affect the difference? No, definitely not. So here's the key, they gave something else. So that's going to be an experiment. It's going to be experiment. They have some influence. Okay, this next question, it always causes problems. So we're just going to skip it out because I think there may be more than one reasonable answer sometimes. Okay, which of these statements are true? Well, experiments can cause cause and effect. Observations, um, you make an observation study and you think you see some cause and effect, and then you set up an experiment to prove it. So that kind of where observational studies come in as a preliminary to the experiment sometimes. So that's a good choice there. Okay. Um, okay. Create conditions. Observation and create don't go together. No. Surveys compare characteristics of interest. No. Observational studies do some comparing. Surveys just take the info. Okay. Randomization reduces the influence of confounding variables. What's a confounding variable? Well, that's those variables that you didn't think about that still had an influence on the situation. And so, so do people like to go do activities at Park A or Park B? Well, what if it rains at Park A and not at Park B? Well, that's a confounding variable that you can't really take into consideration. So, but randomization helps that situation to be better. So that's one of our choices. Observational studies, unlike experiments, involve only existing conditions. Yeah, you don't bring anything with you. You just observe what's already there. Surveys do not involve randomization. They should. They absolutely should. And a survey that doesn't is not a very good survey. Okay, kind of deal. All right, got another guy here. Here's another couple of questions. These look at those, and 8 and 9 on the next page is just A, B, and C. I would do just A, B, and C on those. All right. So, guys, we talked a little bit about statistics. This is our first one. We're going to talk about normal distribution on the next one, and then margin of error on the next one. Um, hope that's helpful to you. You have a nice day.